What's up, bro? I'm Mason here, and today I'm going to talk about the absorber design. So let's crash straight into it. This is an absorber. The main goal of this system is to absorb as much gases as possible into the liquid state. In this case, I want to capture sulfur dioxide and trioxide into the solution, which is going to be sulfuric acid. With that, we are going to make oleum. It is useful and it can be diluted up with water and it will form sulfuric acid. So one part of oleum will produce two parts of sulfuric acid if we dilute it up with the right amount of water. So the problem in this design is that I will show you the principle behind it. On one side we have price, corrosion resistance and effort. We can prioritize all three of them, but we will have to compromise, because if we want a low price but also low effort, we will have to give up corrosion resistance in a big way, because we will have to not all entirely give up corrosion resistance, but as I said, compromise. With this design, I intend to use readily available materials, low price in that sense that this will be a glass jar and it will have a sealant around it. It is like a mason jar with a cap as like this little metal rings around it. I will have it up on screen. So that will be drilled out. Design is like a concept art, but I didn't want to, like, you get the point. So this is like a simplification. For this reason, the lid of that, basically there will be 4 holes drilled into it, not in this specific shape, but I will have to come up with some other pattern because my current design. In here we have Viton tubing that is like one of the most resilient materials that I can use, that is not metals or any other stuff. Basically this is like fluoropolymer that is very resistant to chemicals, and after I think PTFE is the second best material that we can use. PTFE is not readily available at my location and I can't really get a hold of it, plus they don't really make tubings like this. Start off, I had this mason jar mania, basically coming from a place where I don't want excessive laboratory equipment that is really hard to get and expensive and also like very specific. So I want to utilize everyday objects and everyday things that can be repurposed into these tools. There will be problems, as I said. In this case, I have changed up the regular silicone tubing to Viton, because you can use silicone, that's for certain, but it will not last as long, and as I said in the design principles. So in that case, when you want corrosion resistance, you will not be able to get it only with like putting more effort. So to like have less corrosion or have the thing working, you will need to put more effort into the system, meaning that you will need to reglue it and replace the damaged and worn out pieces with new ones. So for this reason, I am going to use an almost all glass container that is going to seal the whole system up. There will be 4 inlet hoses, as you can see, or like hoses, 2 for 2 inlets and 2 for 2 outlets. The one on the left here, you can see this will be a outtake or exhaust for the pump, the peristaltic pump that will circulate the sulfuric acid and oleum mixture in the pipes, this and this. So this is the intake for that. So this will spray in the sulfuric acid, and this will on this pipe it will suck it out. On this pipe we get the intake, basically the sulfur trioxide and dioxide and air combination coming up, and to this bubbler. The bubbler is going to bubble it through the sulfuric acid, and that's going to come up here. Above this line is representing the line of the sulfuric acid, and after it basically reacts with it here in the fluid state, it will eventually come up and be sprayed on top of, basically the sprayer will spray extra sulfuric acid onto the gas that is escaping, so it will have a better and higher efficiency of absorbing the sulfur oxides into the solution. Basically, this will give us a less need for volume of sulfuric acid captured and basically a height of sulfuric acid, because we could do a static absorption chamber that is higher and has more volume of sulfuric acid. But in this case we utilize the like more modern design, that we have a spray system that will spray over the escaping gases and maximizing the gas to fluid ratio, in that sense that we will capture as much sulfur trioxide as we possibly can. Here the gases come in, they will be bubbled, the spray will be not uniform, because this is like the current design that I am on, but I will probably develop it into a higher efficiency and better spray pattern that I want to. This is like a spray nozzle that I 3D print from PLA or some other materials like polypropylene or any other stuff like that. This will be replaced like more regularly than the Viton tubings, because this is not as durable as those materials. But I am more okay with that, because this doesn't need to be glued in, or it can be replaced fairly quickly. The only problem with this is again the corrosion resistance. But what I found is that maybe it is a cope. I don't want to, for the exact reason, to be like be on a cheaper side, that I don't want it to cost me a lot. Also, I don't want to wait for the delivery, because I can't really get these at my home country, so I outsource them from like China or whatever. So I don't want to wait that long, one hand, and these are usually made from plastics, so those are going to dissolve as well. And if not, then they are made of metals like brass or stainless steel or whatever, but they are not corrosion resistant either, so they will be ending up in the sulfuric acid slash oleum mixture, which is not really preferable, in that sense that if I will use this mixture using like PLA or something that is organic, in that sense that it will decompose into carbon, and the carbon will be like eaten up by the sulfuric acid, but yeah, that will like use up some, but the steels would also use up some sulfuric acid. It will not contaminate the made sulfuric acid with further metal particles or something like that. So I will be able to use this as fairly pure sulfuric acid, so I will not need to re-boil it and distill it and waste a lot of energy to purify it further along. This would be the setup. Maybe this will be modified in the future, but this is what I have been thinking about, and this is what I came to in the conclusion that I have thought about a lot of materials, a lot of designs, a lot of ideas on how could I seed it and how could I actually make it work. This is what I came to at this current point of time. This design of the basically this, they call it spray nozzle, but atomizer would be a better statement, in that sense that we want to atomize the water stream in or jet into a very fine particle size, so we want to maximize the surface area. So the finer the droplets, the higher the surface area, the better the absorption is going to be. And yes, this would be the main like reason that I make this video, so I will be remembering, and if you found some value in this, then you can actually use it yourself too. So thanks for watching, and if you liked it, then make sure you subscribe and like and all this bullshit, get do the hard work, especially when you don't feel like it. Mwah.